Hello again, this is Mark Summers from Summers Technical Services. Do a quick video to show you how to do this assignment 09A from that Mott textbook. So I've got a beam. This is what I've uploaded for you on Canvas. And you'll want to change your beam to match your beam. So you'll go, this is my beam with my geometry. So you'll go Tools, Equations, and you'll change these global variables. This is the original beam from the original problem. And you want to change all those parameters there. The 48 stays the same. That's the length of the aluminum plate, but all the other numbers change. And that R value is on that second image file. Everybody's got a little different radius on there. So change all those numbers. And radius is this radius right in here. That'll make your I value correct. So mine's already set up. I'm going to check the material, edit material, and we've got, you want to make sure you've got English units. Solving the problem in English, and it looks like it's about 10 million psi, which is what we use to solve the problem on our hand calculations. So that'll work just like that. So now that I got my model set up, we're going to do the simulation. So I'm going to go click on the simulation tab. If you don't have it, you'll have to go Tools, Add-ins, and add that simulation tab. So I'm going to go to Simulation, New Study, and I'll call this 09A, and this will be part one. We'll do one for each of the parts of the problem. The first one is without the plate. The second one is with the plate. And now I'm thinking about it, I'm going to get out of here and get rid of that plate on this one. So I want to go find that feature and just right-click and suppress it. So now I've got that place gone, so now I'm going to run the analysis without that plate, and I'll run it a second time with the plate. So we'll go New Study, and we'll call it ENGR 3311, ENGR 3311, 09A, and I'll call it part one. And we want a static analysis. Say OK. And we'll answer these questions from left to right. We'll apply material. I've already applied the material. There's the 10 million Young's modulus. Even though it's got tensile strength and yield strength in here, we're not calculating stresses, we're calculating deflections. So the parameter we need is E. So we'll apply that, close it, and we'll do the fixtures. And so I've got a hinge on this bottom edge and a roller on the back edge. So I'm going to go fix geometry. And I'm not going to grab this face because that whole face is not constrained. It's just this bottom edge. So I'm going to grab that edge right there, grab that edge right there. And on my 4K monitor, I can't see those little things. So I'm going to come over here and bump up the symbol size to 300 and say OK. And just double check to make sure there's arrows going in all three directions, because I want that to be fixed in all three directions. So spin it around this side. Similar thing on this end. This is a roller joint, so I'm going to say fix geometry again. I'm going to grab this edge and this edge. I don't want all three directions to be constrained, so I'm going to come down here to advanced, and I'm going to say what am I going to say? Standard, fixed hinge. Here's my two edges. I'm going to come to advanced, and I'm going to define it by using reference geometry. I want to define a direction. So there's my two edges I'm constraining. I'm going to make this box active by clicking on it. This is the face, edge, or plane for direction. And I'm going to select this face right here for the direction because I want it to be able to move in that direction. And so perpendicular to that direction, I want to leave that not selected because I want that to be able to move. I'm going to turn this one on and this one on, the other two directions. So now I've set these displacements in the other two directions to 0, and this last one that's normal to that face is going to be free to slide back and forth since it's a roller joint. And I'm going to say, I want to bump up these, you probably don't have to do this, but I'm going to change these symbols again so I can see them on my monitor. And say OK. And double check to make sure, yeah, it's not going to move up and down. It's not going to move left or right, but it can move in the whatever direction that is, Z direction. So that's exactly what I want. And I'm going to go to the next button here. I'm going to say loads. Put a force on, and what I've done is create split faces on here, and so these lows are concentrated lows, but we can't put them on an edge because it would create an infinite bearing stress on this outer surface because the area would be zero. So I just made a little narrow width here to simulate a concentrated load. I'm going to select that one. I'm going to select this one. My numbers say it wants to be 300 pounds on each, so I'm going to change to English. I'm going to make this 300 pounds. Your number will be different. And I want per item because I want 300 here. Excuse me. 300 here and 300 here. So that looks like what I want. I'll say OK. And now I'm ready to run the analysis. So I'll say, well, I got to mesh it first. I'll create a mesh. I'll slide this over all the way to fine and see what kind of mesh I get. And it looks like a pretty lousy mesh. There's only one element across that face, but I'm going to give it a shot and see what it looks like. We'd want to do a convergence study if we really want to get some accurate stress values, but we'll check the displacement and see what it looks like. So now I'm going to go ahead and run it, and it goes through and does its thing, and there's my analysis. I'm going to turn off the form result like I like to do. I'm going to ask for results. I'm going to right click. I'm not going to say define stress plot. I'm going to define displacement plot. And it looks like I want the displacements in the y direction. So I'm going to ask for u, y in inches. And say OK. Now I've got my displacements. The red is obviously 0 where it can't move. And it goes all the way down to 0.26, negative 0.26. And that was the number that I got on my hand calculation, so that's good. And just for fun, I'm going to come in here and grab this plane and do a cut plot like I like to do. There's the plane, Plot Tools, Section Clipping. I'll say OK. And I'll space bar and I'll look at that thing right into that face, and I'll do Plot Tools, Probe, and if I probe right here in the middle, it looks like it's about 0.26 all the way across this top edge, which is what I expected. So that looks good. And before we leave this model, let's come back over here. Let's get rid of that cut plot. Section clipping, I hit the reset button down here. So I'm going to go back to the model and check and see what my I value was. I had that number on my hand calculations because I looked it up on the table that I gave you, those C channels. So I'm going to go back to the model real quick. I should have done this earlier. I want to go to evaluate section properties. I'm going to grab that face, say calculate, and then I value I got from the chart was 1.53, and sure enough, there it is right there, 1.53. So I feel good about the model being correct. All right, so now let's come over here. Let's make a copy of this simulation. I'm going to copy study, and I'm going to call it O2. Study name, I'll rename it right here, I guess. 2. And say OK. So now I got a second tab down here, and now I'm going to go put that plate back on, the 1/4-inch plate. So I'll go back to the model. I'll right click on that and unsuppress it. So now I've got the plate back on there, and so my model should still be correct because all these other values will stay the same for the tools equations. C channel all stays the same, so that all stays just like it is. So now I've got that plate on there, so I'm expecting a lot less deflections, and I'm hoping it's going to match my hand calculations I did. So now let's, we've already got all that's set up. Got the 300-pound load. Go back to the study over here. There's a 300, there's a two fixed ends. One of them's a fix and one of them's a roller. There's the force is still 300 pounds. And I've already measured it, so I'm just going to run this study and see what it says here. So there we got the finished results. I'm going to turn off the deformed results. Again, I've got to go ask for displacement plot I want. Right click, define displacement plot. I'll ask for the UI again, Y displacement in inches. Not meters, how about inches? All right, now it looks like my deflection is 0.0097, 0.098, right? Two places go 1, 2, 098. And my calculated value was 0.093. So I'm within 5 thousandths. So I feel pretty good about that. So if you get within 5 thousandths, you should be good. So this is for fun. Do the section cut, section clipping. So I want to grab that plane again, which was the front plane. Plot tool, section clipping. There we go. I'm going to look at it head on. And I'm going to go plot tools probe. And I should get my 0.098 number. Here in the middle. I get close to the edge. 097, 098. That looks good. So you will, for your turn this in, just give me a plot here so I can see your deflections, and they should match within about 5 thousandths, 5 or 10 thousandths to the calculated value you got on your hand calculations, and send that as a screenshot before class starts, so you get those points for that part of the assignment. So I'm going to back off one more time and go look at the model and check to make sure my I values matched. Reset that. Go make sure my I values match. My moment of inertia matches what I had on the my hand calculation. So I'm going to go grab this front plane again. Back in the model here, cross section, and I'm looking at my hand calculations over here, and I got I used for I. What did I use? Where is it? I used 4.66 for IXX. So I want to go evaluate section properties, grab that face. It's got that 1/4 inch plate at the bottom. Recalculate, IXX is 466. So that's why I got the right answer, because I have the right model. So anyway, that is should get you going on that part of the assignment. So make sure to send that spreadsheet, your hand calculations, your screenshot, bring all that stuff into class at the start so I can pick those up and grade those. If you have any questions, stop by during office hours. Otherwise, we'll see you in class this week.